Hello students, in this video we are going to discuss about bootstrapping and porting. In the last video we have discussed about major data structures in compiler, like how the data structures are helped in translating the high level language statements into low level. So assume that a compiler is developed and we have some compilers, and by using the existing compilers how we are going to develop the new language compilers, whether it is for the same language or same machines, sometimes different language in different machines. So based on that we are going to have different compilers, and first we'll discuss what exactly the bootstrapping is. See, bootstrapping is simply developing a compiler for a new language by using the existing compiler. Means sometimes we are going to generate like C. The first C compiler was written in Fortran, but remaining all the versions of C were written in C only. So using the C compiler to develop the new programming language, that's called a new version of the same programming language is called bootstrapping. Then you go for it. First Java compiler was written in C language, but the remaining versions of Java were developed in Java compilers only. So developing the writing the compiler code in the same or host language is called bootstrapping. So now here you can take this X and Y. So first we are developing the X language in Y. So we are writing the code for X in Y, and that is going to be worked in Z. So now this X is ready. The new compiler is ready. So by using this compiler, we are going to develop a new compiler called X in machine M for the targeting code Z. Here where we have written in Y. So but here we are going to execute in machine. This is our targeting. So by using this compiler, and we are running this in another machine, so that the new compiler is going to be worked in that targeting machine. So same language we are using, but developing a compiler for the different host, right? That is called bootstrapping. So let me explain with the sample examples, the familiar examples. So here we are developing a Pascal translator for C++ language. So our new language is Pascal translator for C++ language. And where we are writing that, we are writing in a already developed Pascal translator for C. So we are using Pascal translator and right, but we are developing for C++. We're writing the code in Pascal only, but that was meant for C. So once this is developed, then we are executing that code, the Pascal translator for C++ in another machine called M. So once it is executed in the machine, then it is going to generate the target code. Now we have the Pascal translator for C. So here we have the Pascal translator for C++. Then now you can use this Pascal translator for C++ by writing code, or you can use it by convert high level language statements into low level. So in simple step, first writing the Pascal translator code in C, then we are executing in the machine M, so that the Pascal translator for C++ will be generated for this machine. Now this is ready. So this part of is new Pascal translator for C++. So if you give high level language, this translator will convert into low level language. See, bootstrapping means developing the compiler in this host language, bootstrapping. Sometimes we should change the compiler code to work on the different machines. So assume that we have developed a C compiler with the 7 phases: lexical analysis, syntax analysis, up to intermediate code or target code generation. So as we have already discussed, from lexical analysis to intermediate code generation, that is machine independent. So and target code generation and code optimization is machine dependent. So assume that we have written the lexical analysis to intermediate code generator, okay, which is machine independent. Intermediate representation is machine independent. Then target code generation, okay. So target code generation and target code optimization, they are machine dependent. Now these machine independent phases are constant. We are not changing here. By changing these two phases, target code generation and code optimizer, we can use the same compiler for the different machines. Assume that the first C compiler was written for Windows operating system with the 7 phases. And if you want to make this C compiler to work for other machines, you no need to change all the phases. Just changing the machine dependent phase is enough. So that sometimes we have to change some intermediate representations. So the changing of phases are some part of the compiler to work on a different machine is called porting. So generally the porting is going to be done in synthesis part of the compiler phases. Like we have discussed what are the analysis phase and synthesis phase. So mainly we are going to change in synthesis part. And see, bootstrapping means compiling the compiler program in host machine or language. Porting means changing the compiler to work on different machines. And we have a different other two compilers called native compilers and cross compilers. So what is native compiler? Assume that you are writing the code in Windows operating system and compiling in Windows operating system, and the same code is going to be used in Windows operating system only. So writing in same machine, compiling in same machine, and generating the target code for same machine, that is called native. Generally the normal C compilers are going to use the same. So compile the generated code for the same platform on which it runs. So simply the general, all the general compilers are comes under native compilers only. But cross compiler means assume that you are writing the code in Windows and run the code in Windows, but actually the generated target code will work on the different machine. That's called Linux. So where you have written and where we have compiled, there we are not going to use. We are using in different machine. So we are just converting the code to different machine. So that's called cross compiler. So in the next topic, we are going to discuss about the role of lexical analyzer.